Hi, welcome again. So in this part of video, these are the content which I'll be just going to discuss. The first thing that I'm going to discuss is exporting CSV or Excel, sorry, importing, I'm sorry, importing CSV and Excel sheet in R, and then working with the CSV and Excel sheet in R. Uh, in the last video, I discussed the basic wizard through which you can import data, which is what we did. We imported text file. I'll discuss about the same wizard again, but in a little faster. I'll run fast and also discuss the CSV wizard right now and Excel sheet wizard actually. Once we import data into R, then we will do some basic operations with that data, which involves finding a specific number, finding order, the sorting a variable, and sorting the entire data frame based on variable. In the last video, we imported a text file, and using that text file, we worked with a little bit with that data on the text file and prepared a very basic plotting. We'll just advance our level of plotting, move to another useful tool in R, and apply that for uh, analysis or plotting for our plotting our data. Okay, so this is the kind of content which I'm going to cover in this video. Now, what I'll do, as I said, I'll be uh, side by side writing all commands and everything in a RScript files, for which I'm going to open a RScript file. Okay, once you open RScript file, this is my strategy. Normally, how I work, first what I do, I set my working directory. So I'll just go in a faster mode because we have already discussed this. My working directory is in exercise and data folder. So that's my working directory. Once it appears here, I'll copy, sorry, I'm sorry. I'll copy this, Control C, and paste in my uh, Control V and paste in my R script. Okay. So this is uh, set working directory. Now the advantage I've already discussed, so I'm not going to discuss this. This is step number 1, which is done. Now next step is data import. Once I set my directory, I'll do a data import. Now if you go back to the last video, what we did in the last video is we use this base package wizard. Okay, base package wizard, and once it is popping up a window, you can actually direct your window to the file that you have, and from there what you can do is you can directly import your data. Now last time we worked with the file all India, this time we are working with the file contingency tables. Okay, now the thing is the file which I have already given to you is Excel sheet. So now what you have to do is you have to convert your Excel sheet into CSV. So currently we are working with it is much easier to work with CSV file, and CSV is has much more interoperability with other softwares. It is a kind of advice you work with CSV, and R by default works with CSV. To work with Excel, R need a specific package. If you're working with the current version of R, possibly these specific packages are already there in your R, but in order to save your file and something, you have to have another package. So that's a thing that you have to keep in mind. So I'll just go with the basic version. So in order to do this, I'll open my Excel sheet. What I'm going to cover here is basically how do you convert your data into CSV actually. So first you open your Excel sheet. It will take little time. When the CSV file gets open, sorry, Excel sheet gets open, what I can do is I can convert, then I look at the specific sheet, select the specific sheet and convert that into uh, CSV. The advantage with CSV is, I'm sorry, I'm not working with a little bit. I think I missed. Sorry. Let me go back. Uh, let me go back. I'm sorry. I think I missed. Uh, I did not share the uh, folder with you when I was working with this. I'm sorry for that. So this is the Excel sheet which I am going to open. Okay, it's taking little time to get open. Now my folder is open. So this is the contingency table which I've shared with you. And this folder is now you can see in your screen also, because earlier I have not shared. And this is the content of your contingency table, which is Excel sheet. The thing is, how do you convert that into CSV? Go to File, Save As, define the folder where you want to save. Okay. Once you identify the folder, contingency table is already there. You look at CSV. There are various versions of CSV. The version which we wanted to use is comma delimited. Okay. CSV. This is there are MS-DOS and other. I think better to use comma delimited. Okay. You can change the name also. I'll say CSV, sorry, CSV, and you save it. So this is how you can save your seat. If there are multiple seats, you need to save. And there will be warning, you ignore that warning. Okay. So once you save your seat, go to the folder, show you the CSV file which is appearing over here. So your CSV is saved now. Now you can go to your R Studio. Now I'll go to the import wizard, which we have already done last time. And now I'll use the basic base wizard. Okay. So base wizard will also work with CSV actually. So let's see this. If you do this, your base wizard is appearing over here. This is the raw data, CSV, because it's defined by comma. This is the name that you can change. What you have, this is a default, it says no, but since this data, like unlike the previous data, there was no heading in the data, this data has header actually. So you have to click yes. If you're clicking yes, the actual header will appear over here actually. Okay. And then you look at comma is the default, like in earlier case, it was white space. In this case, it's comma by default. So it is automatically coming. We are not going to import. This is one method actually. Okay. The second method is you can take a CSV wizard. So there is a text from text read R package actually. Okay, this is already there in your system if you have installed the recent version of R. So you can take this. It will open up a window. What you have to do, you have to browse. The advantage with this window is you can, if there are online data, okay, CSV file online, you can specify URL. It will take the online data actually. So now in my case, this is the data CSV. I'm going to take it. This is the preview of the data, how the data looks like. Okay. This is, and in this case, when R is importing data, R is considering this data as table. Earlier, R was considering data as data frame. As I said, there is no difference between table and data frame, but table offers many advantages over the data frame. So that's it. The advantage with this kind of window is, you suppose you want to skip some rows. Suppose I want to skip 5 rows. Okay, let's see how does it skip 5 rows. It can skip 5 rows actually. Now first 5 row including the header has been skipped. Okay, so you can skip number of rows if you want actually. So that's an advantage, and you can see the code is actually automatically code is appearing. Currently it's a no skip by default. Suppose you say there are 5 row I would like to skip. What is happening? Just look at the code. This is the kind of preview of the data where 5 rows, top 5 rows has been skipped. eh? And this is the code. After this, reads underscore CSV contingency table dot CSV. There is another option which is coming, skip equal to 5. So automatically it's coming actually. If I say skip 0, this will not come because by default there is no skip. Okay, so you have to be a bit careful with this. And once you do this, what I'll do, I'll not do an import. Instead, I'll simply copy this code and paste in my R. Now this code is a part of package readr. Okay, so you have to call this package also. That's why this is the way. View, I don't want to view the data right now, so I'm just skipping this. Okay, so this way you can import a data. So once you do this, you can change this name. You can say, okay, data CSV. Okay, and you can run this, and this will import your data in R. This is data CSV. Look at data CSV. Actually, data CSV is nothing but column. This is a detail how it is done. It's a data frame. It's actually a table. You can say, look at STR, structure of your data frame, data CSV, sorry. And it says, look at the beginning of the instruction. Data CSV, it's a table of 19 rows and 13 variables, 19 observation and 13 variables. And this is the structure. Hmm? So it gives you complete detail. You can double click over it also. You can see this data. Okay. So now this data is imported using the CSV wizard. Actually. Now what are we going to do is in the next step, I'm going to import data using directly from Excel sheet. Okay. This is a kind of a capacity that the recent version of uh, R has. Earlier version required a specific package. There are many packages that can deal with Excel data files. Uh, this particular package, which is already there in R, is the base package actually. So we'll be using this. We'll again go to data import. Now from Excel, I'll click from Excel. So this is the third wizard. You can click out data, click over your data. A browsing window will appear. You have to select the file or through URL also. You can get the data from URL also. Okay. Now this is a preview of the data. Again, data will be taken as or imported as table. This is the command library read Excel is a package. It requires this package. Contingency table, you can give name. Read underscore Excel is the file of that package that will load the data. And this is the name of your data. Now, what you have to understand this name you can change. eh? I can say data Excel. Okay. Seat, because Excel normally has number of seats. Currently, by default, it has only one seat, seat one, or default actually. It is because there is only one seat, default. If you want to specify seat, you can specify here. The seat one will appear as a part of code. So advantage is you are writing a code, but you are using the wizard, and wizard is giving you the code actually, and that you can copy and paste. This is a kind of range a data has. Number of rows, skip right now 0. You can skip again in the same case. You can skip 10. So skip 10 will appear, and this will be a kind of preview of your data. Okay, so this is a kind of uses of skip actually. If your data is very large, it is not easily loaded. You can't easily load in your R system, depending on your uh, computing resources. What you can do, you can skip unwanted rows actually from the data. Hmm? That's very important actually. So this is point actually. Okay. Now what we'll do, we'll simply copy this and paste in. I'll not import directly. I'll simply copy the command and paste in my R. Okay. Now this is I'm running it. If I run it, it will appear in my uh, console. At first, it will read the library read Excel package, and then it is loading the data. Data Excel is appearing over here. Again, structure of the data Excel is table. This is table again. You can look at data Excel. Roughly the same structure as the data CSV. Both are tables, so there is no difference. The only way is the writing command slightly different. Function is different. Read Excel in this case, read CSV in that case, and they have different requirement of package. So CSV required reader package, Excel requires library Excel package. Both of these packages are already there in your version when you install your R. So you need not to install these packages actually. It's already there in the base version. So this is all about how do you export data from a CSV file as well as Excel file, and there are three methods. You can use any of these methods in order to load your data. Going back to the notebook, as we discuss, what we are going to discuss, I'm using only one data, so I'll just remove the other one. Okay. What I'll do, because both the data are roughly same, the structure and now everything is same. The only method of importing was different. I'll actually look at some issue like finding a specific number in the data. If you have a very large data, how do you find a specific number? I'll look at the data and look at this. Finding orders, finding variables. And that is again order and variable. I'll do it together, and sorting variables. Okay. So that's the thing actually that we'll do. So basic operation with data. And I'm keeping data Excel right now, removing data CSV. Okay, let me remove this. Run this. Data CSV is removed. Now with data Excel, let us look at what is data Excel. It's a data of districts of Punjab. There are roughly 19 districts in Punjab, and there are a lot of information related to that districts: geographical area, net zone area, gross cultivated area, net irrigated area, gross irrigated area, SWIA, GWIA, number of borewells, cattle, buffalo, sheep, goat, horses. This is the kind of data that we am getting actually. Okay. Now, what I want to look at the specific number. So if I say, let me pick up this variable, gross irrigated area. Okay. So, okay, let me pick up this variable. How do I pick up a variable? We have already done in data frame class. Uh, I'll call GIA. Okay, so this is what data Excel. This I'm calling my data frame data Excel. Then I'll call dollar, means you're calling your particular column. So gross irrigated area. Okay, this is my data. So this is the GIA, which is number 19 numbers. This is the gross irrigated area. Okay, this is how you can call. Suppose you want to check which data set is in GIA, which data is actually greater than 500. Okay, so what is the command? So what I'll do, I'll record the row numbers or a number of the series number of this data which are greater than 500. So I'll just simply call F. I'm sorry, I'm calling here. I'll simply call F over here, and I'll use the command which, and I'll call the variable GIA, which GIA is greater than 500. Okay, if I call this, let me run this. It will record F, all these row values of F that has value greater than 500. So you can identify, and this is just an example which I'm giving you. You can look at your condition and identifies the values which are uh, actually satisfying the condition that you have imposed on the data. Okay, so like F3, F3 means the third value of F is greater than GIA. Let us test it. So GIA is my variable, and third value of this is, let us look at 595. Then what is sixth is 535, which is greater than 500. Then 11, which is 552. Then 17, 874. So all these are greater than 5. Suppose you want to save only those part in the data frame which are greater than 500, for which the GIA is greater than 500. Now we're talking about saving a data frame, a part of the data frame. So what I'll do, I just wanted to save that data frame. So I'll simply call some other data frame data 1. Okay. Data 1 is a part of data Excel in which data Excel dollar, because the criteria that we have taken is GIA, okay, is basically referring to all values which are greater than 500. So F is containing all values which are greater than 500. Okay. So if it is, sorry, yes. So it should be data Excel dollar GIA. Oh, sorry. What you can say simply, I'm sorry, because this GIA is what it is doing. This F is recording the row numbers. So you can call data frame is also a form of matrix. So what you can simply do, you can simply record your row numbers and all columns. Okay. If you do this, what it will do, it will filter out this data Excel for data frame according to row numbers and save in data one. Let us look at. Let us look at what is, let me, for the time being, something is going wrong. Let me look at, this is data F, that's there, all these values actually. Okay. So I'm sorry, I should not call this, I'm sorry, that's my mistake. It should be like this. So your new data frame is this. Okay. Let's look at data one. And how does data one looks like? Only those districts which has GIA greater than 500. Okay. So this is how you write it. You can directly filter out your data using the matrix operations. Actually. So you are actually, this is what you can say, filtering your data using matrix operations. You can do this with the large data set. Sometimes you don't have a data as per your requirement. They're spread over the entire matrix. You can identify the kind of pointers where your data as per the conditions are there and filter out your matrix. So this is the way you can do this. Now the next step is what I'm going to look at is ordering, record ordering. Okay. So if I call F1, let me call in this, and I use the command order, and I'm using this command order. Sorry, I'm sorry. So I'm copying it and pasting it. Okay. Data X according to GIA. Let me look at the order. So my order is F1, and F1 is order is arranged 13, 16, 19. It is arranged either in an increasing order, in a decreasing order. The default is, I guess, in increasing order. Let's check. Help order is my function. Let's check what is showing in help. So you look at order, its default is decreasing false. Okay, decreasing condition is false. It means it is an increasing order. Let us check it. Okay, so I'll do this. Uh, Suppose this is my data Excel dollar GIA, because this is where I'm doing operation, and my order is F1. Okay, according to F1. So let us look at 124, 129. This is an increasing order actually. So by default, if I'm not giving anything in the order, default is increasing order. If I say decreasing equal to true, then it would be a decreasing order. So what it is doing, it is simply recording their row numbers in F1. Which row number is the lowest, and then how it is moving in your data. So it is recording the row numbers in data. This is very important because right now it's simply row numbers. I may not be able to identify anything. In order to know the data, I can use this row number and call the data actually. Then this way I can take it. But suppose I want to filter out this, okay? One way is to sort the vector data is I can simply directly S1, I can simply directly sort the vector, okay? Data Excel dollar. What I'm going to do is I'm sorting the particular variable in the data. So this is the variable. If I save this in Excel, what is Excel is actually recording that numbers, and by default I said default order is increasing. So it is increasing. It is actually sorting your particular variable. This is method of sorting a variable. Okay, so sorting a variable in an increasing order. Default is an increasing. But how do you sort a entire data frame keeping with the condition of one variable? So one variable is sorted, but accordingly you want to you want entire data frame should adjust according to the sorted order of this one variable. Actually, that's very important. This is normally we do in Excel. Actually, we have to do this in the Excel. We identify a condition column, and then accordingly it adjusts the entire data frame. In R, how can you actually do this? In order to do this, I'll say data sort. Okay. Again, I'm using GIA as my criteria, and actually I'm arranging GIA in increasing order and want the entire data frame to adjust according to GIA. Okay. So in order to do this, what I'll do, I'll call my data frame, and then I'll specify, because what I've done is I've actually recorded order in a variable F1, order of GIA, increasing order of GIA in F1. So I'll actually specify the row numbers of all this ordered framework and store everything and put in the column. Actually, that's very simple actually. So this is what you have to keep in mind. Once you do this, what it will do, it will create another data frame sort. It is now it has the change the arrangement of the districts in the data frame, and this arrangement of the district in the data frame is actually changed according to the sorted order of GIA. So lowest, the Barnala in Punjab has the lowest GIA, whereas Jalandhar is this much, and the highest GIA is Firozpur in Punjab. Actually. So this is how the entire data frame is adjusted. Actually. Okay, so this is the second important thing that you can do with your data frame. If you have a very large data, very huge amount of data, how do you identify the columns, particularly rows of a particular variable? Based on that, you can adjust the entire data frame. The next step that we were going to do is some level of advanced plotting. So remember in the last video, I told you how to make some basic plottings and understand the important plot parameter using this basic plotting examples. I'm again jumping into the specific packages and code because it will take a lot of time. I'm not covering the background of or the basics of the plotting, but I'll just on the go when I'll work with data, I'll describe plotting and discuss something about those basics. So in this part, what I'm going to do is basically, I'm going to use the package ggplot. And I told you earlier, this is one of the most important plotting using ggplot. So ggplot is a package actually, and this is the most advanced and important package in R. Using this, you can make very fancy plots, useful plot, or plot that can actually give much more information than the usual way of extracting information from the data. So this is the plot we are going to. In order to call ggplot, first what you have to do is you have to install this package. If this package ggplot is not there in your R, you have to install it. Okay, this is on. I'm going to install the package. If you're working with some advanced version or packages in R, ggplot comes as a base package actually. So it sometimes automatically get installed, but if it is not there in your R, you uh, install ggplot package. This is very important. Once you install a ggplot package, you have to call this ggplot package. And how do you call it? You will call, well, command library. Okay, ggplot. Okay, so ggplot2 is the name of the package. Okay, done. Now, what I'll do, I'll discuss about this package, but let me create a basic graph using the package, and then we'll discuss about some how does this package work. So I'm copying it and pasting here and then discuss. So this is the command which is copied and pasted. In order to make it better, what I can do is I can put in the different lines. One of the important advantage of ggplot is you can create the additional feature of this ggplot by using the plus symbol actually. Okay, by using the plus symbol you can create additional features. So what ggplot requires, I'll just work with some basic command. How does this basic command work? And then I'll tell you. Okay, so I think what I'm going to do is going to write some basics about this ggplot. So first you have to call ggplot. So what ggplot, when it normally it actually identifies the plot parameter. When you define a plot parameter, you can define the plot parameter according to your requirement, and it saves in a particular variable where you can recall these plot parameter again, and then you want to make plot, you can make quick plots. At the moment, I'm not saving in a plot parameter, but this is how it works. But let me actually directly work with ggplot. So the first function in ggplot is ggplot, and in the ggplot, what you have to describe which data you want to work with. Okay, so the first thing that you want to say data, and then you have to specify the aesthetics. This is how the plot works actually. So I'll just modify my first line. So my command is ggplot, and my data is which data I'm working with. I'm working with the data Excel. Okay, so that's my data. Okay, and then I have to specify aesthetics. So what I'm doing right now, I'm actually making a bar plot and showing the gross cropped area of all districts in Punjab. That's the way I want to plot it actually. So this is the first kind of plot, which is bar plot, data Excel. Okay. Hmm? So the command method, how it works, the function you call, then you have to specify which data frame you're working. Remember, ggplot always works with data frame. You can't simply provide some data and work with this. You have to convert that data into data frame or table. These are the only two arrangements with ggplot is very active. So that's very important. You have to keep in mind. You have to convert your data either in data frame or table actually. Okay. Once you define your data frame, the next one is you have to define aesthetics. What do you mean by aesthetics? Any graph you have axis and y axis. So you have to specify what variable you're keeping in x axis and what variable you're keeping in y axis. Right now, this is the background. I can define aesthetic as much more, even more meaning, but right now you take this. So you have to define your x axis and y axis. Now, specifically in case of bar plot, if you remember a bar plot, there are actually the categories in x-axis and values in y-axis. Okay, so bar plot normally requires the values actually. So what I am going to do is aesthetic, and then uh, x-axis are categories. I'm defining categories. So let me actually look at again data. Where is data Excel? And then we'll get to know more about it. So my data Excel, district is my categories, and GCA is a number. GCA is a number. Where is GCA? GCA is this. It's a number, and these are values actually. So in my bar plot, so this is my data frame. This is the categories x-axis. These are values. This is the first line. With this first line, what I can do, I can create a very basic the plot will not appear right now because it doesn't know which plot I am calling actually. So if I run simply this, it will actually create the parameter of the plot. Okay. I'm sorry, this ggplot library I have not called. So I need to call this library, otherwise it won't work. So let me call the library first. This is what I've done. And now if I run this, what is actually happening? It will create a basic plot. It has created district. It has created some very basic and GCA, but not data. It has not plotted data. The next line in this, I need to specify which GeoM. GeoM means geometry. It can be line, point, bar, anytime. There are thousand, I don't say thousand, but there are many such geometries you can plot in your graph. Okay. So currently I'm calling geometry bar. Okay. Geometry is thing. Then you can look at a kind of basic uh, ggplot package, and the ggplot cheat sheet also you can look at. So ggplot cheat sheet is very useful for you to understand a kind of, it's a kind of compendium of how ggplot command works. You load it and work with that. So there are many such GOMs actually you can work with. Currently I'm calling GOM bar. GOM bar requires some understanding. So one is the static of the graph is identity so that it can plot it. This is bar. So I've already described my ggplot that I'm plotting a bar plot. And I'm filled means you have to give a color. So I'm giving a color red. Okay. Let me run these two. Okay. So this plot is appearing over here. So it's a bar plot. I've described here. You have called GOM bar. So it has actually appeared the geometry of bar of these data. Identities, these individual bar are different. So it is actually making each bar has its own identity. You're giving a color red. Okay. Now there are many things that I can improve in this graph. So this is not very good graph. The thing is, if I keep my district name on perpendicular way, then I can make my graph much more better actually. So what I can do, I can change the parameter by putting a plus command, and then I'm calling theme. So theme, within theme, you can say axis.text.x. This is x-axis. Element text angle 90 degree. If you call this, what happens? You can run a ggplot command with 90-degree angle. Your districts are moving. It's much more cleaner graph actually. Okay. Now the graph is much more cleaner. You can show it to anyone. And suppose I want to make it some line in this in order to show this line is important because anything below this line is not good. Anything above the line is something, is the kind of information that I would like to. So what I can do is I can call another geometry in this plot, GOM H line. H line means horizontal line. Okay. All this GOM data, or you can look at the cheat sheet, you'll come to know what GOM for what actually. So you can call H line, GOM H line, Y intercept. So this is a Y intercept at what point you're creating this horizontal line. I'm using a random number 300. Okay. Just to show this, I can call this color as blue and line width 1.4 times of the original line at which it is creating. So you make 40% higher than the, make a higher 40% higher width of that line actually. So I can put it this and run this, how the plot looks like. It is showing you the blue line and showing it number 300, and this is a kind of complete graph that you can create. This is just a kind of example. You can make the graph even much more better and useful. You can change the number of features in the graph. Okay. You have to understand this, how this command works. So what I have done is I've given you a basic description of how ggplot works actually, but then you have to work with variety of data set in order to get mastery over the command ggplot. Remember, if you know ggplot, you will have a very strong advantage over R. You can produce your data in variety of data analysis in variety of ways. And ggplot is really an advantage in R. You have to take this advantage in your favor. Actually. Okay. So this is one plot with which you can create a plot, and this in this case we have learned how ggplot package works actually. I'm also giving you a background of one more plot in this video, and this is the bubble plot. Okay, I'm directly copying it here. Okay, now what I'll do, I'll save the parameters of ggplot in a variable p. Now again I'm describing a ggplot, but for bubble plot using ggplot. Now let us look at, I'm copying and pasting it. What I'm doing is I'm actually, there are many things into it. So what I can do is, in order to understand this better, I can do is, let me line, comma, I can do this actually. So it will be easier for me to understand. So this is one command, one line, plus, and then after this there is line number 2, and then there is line number 3. Okay. In fact, there is one more line. I'll discuss first this. So what I'm going to do, the plot will not appear directly. All plot parameter will be saved in a variable v. I can call this variable again and plot it. Actually, I can change the basics of the variable later on. Actually. So parameters are what is x-axis, what is y-axis, what is an arrangement of the label of axis, what is the name of x label, what is the name of y label, if you want to creating an intercept, at what label you are creating intercept, what is the geometry of your plot, and so on. So there are, these are the different parameters that you can call. What you can do, you can save these parameter in a variable p. Okay. Now let us look at, again, ggplot, you have to call your, give your data. So in my case, my data is data xl. Okay, and then x is my, it's a bubble plot, so x is my basically GIA, and y is suppose number of bore wells I'm doing. These are typically, bubble plots are simply, you can look at, bubble plots are basically the points, scatter plots by background, but you actually change the size of the scatter plot according to some criteria. So what I'm going to do is I'm making the size of scatter plot according to the gross area of district. Okay, and then color, you can also change the color of your scatter plot, scatter points. And now the criteria which I'm using is, according to the district you change the color, or automatically change. What I will do, I'll take a color, give some random color, but color will be differentiate for different districts. District cannot have same colors. Okay, so that is what it will automatically do. You can specify also, but then you have to go into the background of ggplot. So this is the first parameter. What I do, I'll read this first parameter in my R. So what this basic ggplot package, it is calling this first parameter and saving in a variable p. So it's a list, and all parameters are saved in a list. Now let me plot this p. In order to plot this p, you simply have to type p in your console or in your R, and this is the plot, GIA versus number of bore wells. Since I am not described which plot I am doing it, so it is simply plotting a blank graph. Okay. Now I have to specify what is I'm doing. I'm doing a GM point, and alpha is actually the size of points are 0.5 basically. Okay. So I can say P is equal to P plus, instead of this. This is the first line, and now old parameter plus add this parameter actually. In old parameter you add this parameter. Okay, now the p will have more parameters. Okay, now p has more parameter, all these parameter added in different portion of the list. Let me call p. Okay, now this is how p looks like. Okay, so I've already colored number of bore well, size, and everything. Size is adjusted according to gross area, geographical area. So this much size is referring to 200,000 hectare, and if the size is going greater than this, it is greater than 200,000 hectare. Going lesser than this, it is lesser than it. Then the colors are different for different districts. So these are the different color for different districts. This is how you create your plot. You can say this also as 1.5. Let us look at what happens. P 1.5. Oh, sorry, between 1 you can give. So I'm sorry, alpha between 1 to 1.5 you can give. Let's see what happens. Oh, uh, 0.7. Oh, this is my mistake. Let me call P again. That's my mistake. I'm sorry. Because it's keep on recording on the old variables actually. Now P is this and then P is 0.7. Now it will work. Okay. Because I have already given higher parameter to this actually. So zero point 0.7, this is the kind of thing. Let me say zero point 0.2. What happens? So the alpha is basically the, let me first look at this, run this. P is, so alpha is actually the transparency label actually. Okay. At what label you want to make it transparent actually. I can keep 0.9 also, then it will be more darker. But for this, you have to keep it. You don't repeat my mistake. You have to call P first. Run it because then it is overlaying actually. And then you run it. Okay. Now P would be darker. Okay. So this is the meaning of alpha actually. Now what you do, you create another parameter which is P plus. And now you scale size range 1 to 10 geographical area. You have to give actually this scale size actually. Okay. Now according to geographical area, you are giving a scale size, different scale size, and this is it will actually increase the size of the bubble actually. Okay. So this will increase the size of the bubble, make it much more clear actually. This is how the bubble plot works in this. What I want is I want to create one trend line between GIA versus number of borewell and try to look at which districts are falling above the trend line and which districts are falling below the trend line. Actually. And then I think I'll do a very small interpretation of my graph. Let us look at how it works. So what I'm going to do is I'm going to call a kind of trend line works based on regression. So what I'll do, I'll run a very basic regression in R. Okay. I'm going to run a basic regression in R. So this is my basic regression in R. I'm calling a variable. I'm calling a linear model, which I discussed last time. And the linear model between my independent variable GIA x-axis and dependent variable number of borewells. So the point which I'm looking at, whether increase in your gross irrigated area leads to increase in installation of borewells or not. This is the kind of thing which I'm looking at in this regression. It's a framework of the regression actually. Now my data is different, so I have to describe my data from which data frame I'm accessing the GIA and Excel. So data Excel is my data frame. Okay, GIA and number of borewells from where taking. I'm taking from data frame data Excel. So what I'll do, I'll run this and it will run a basic regression and store the parameter of regression in variable H. And again, H is a list. And remember in one of the live video I told list is very important parameter where number of functions store their output in list. So this function ln store output in a list. Okay, you can call the list later on. Actually, I'm not going into detail of regression right now. What I'm going to do is plot this trend line. So a trend line is a kind of line, and a line requires two important things. If you actually look at the line typically if you have an equation of line looks like y equal to mx plus c. So c is the intercept. So it requires intercept at what point you are intercepting, and m is your slope. So it requires two things. One is intercept, the other one is slope. Okay. Now let me actually run my command and look at when I run my regression, what happens? Regression gives me two important features, M and C, but in R, it's stored in a variable called H dollar coefficients. H is a list you can call. So coefficients are basically the coefficient of a regression. What are coefficient? M and C. So what is intercept in this case? Intercept is this. And GIA is your variable. What is the kind of coefficient between GIA and number of borewell, it is M. Okay, that's a slope. It's a slope. Okay, so you have to keep this in mind. And when you call your line graph, what I'm going to do is, let us look at, I'll copy paste the old command. C. So I'm going to save everything in a variable P. Okay, P, old plot, and then you plot another feature in your variable with G or AB line. AB line is XY line actually. And this XY line requires two parameters, intercept, and intercept is my H coefficient 1. There are two values. So first one is intercept. This is intercept, and H coefficient 2 is your slope. Okay, so slope is basically H coefficient 2. Then you specify what should be the color of my regression line and what is the line width of my regression line. I'm saying you make the width 50% higher than the default width. 1.5 means 50% higher than the default width. And I'm saving everything in a parameter P. So now P is done, and I can call P again. I'll simply type it and run it. What happens? This line will appear. Okay. Now this is a kind of trend line between the scatter points, a trend line of scatter point between GIA, gross irrigated area, and number of borewells. And this is the nature of the line. We can run regression, how regression works. I can look at the summary of regression, summary of H. Okay, it's very high, strong. The significance is high, not very high, but significance is high. R square is 0.2769 actually, and this is the kind of slope. Okay, so there is a significant relationship between GIA versus number of borewells, and scatter points are showing over here. Now this says, in generally, this says that if you increase your gross irrigated area, in your area number of borewell installation will increase. That's a kind of understanding that you draw from this data set. What does it make? It has a consequence of environment. So if you actually increase your irrigated area, borewell numbers will increase, and over a point then groundwater withdrawal will also increase, and then possibility groundwater will go down also, and this will have then implication on your irrigated area actually, or supply of water in irrigated areas. So these are the things, but there is an exception, and this exception is actually this district. Okay, this is I think color is very much matching with this Sangarur. Sangarur, it doesn't follow even with the low gross irrigated area. Number of borewells are very high actually. So people are actually putting more number of borewell. However, the area under irrigation is not really increased. There may be some implications of this understanding. Possibility, because I'm from that domain, I can understand. Possibility, what is happening, that those who are rich, who can afford borewell, can actually, they're normally taking more and more number of borewell. So there may be a disparity between poor farmer versus rich farmer. Rich farmer is having number of borewells, working with it. They're simply irrigating their field, but not allowing it to irrigate to other fields actually. So gross irrigated area is not really increasing because other farmers are not able to access borewell. And the big farmer or medium class farmer, they are able to access more borewell. So they're simply increasing their area actually. So this is a kind of interpretation that you can draw from this graph. And this gives a very good picture, and very good sound in the pictorial quality also gives an understanding. So this is all about this video, where what I have discussed is, I have discussed 2-3 points. One is uh, working with how do you import your data, then how do you do some basic operation with your data, and how to do advanced plotting. In this part of the advanced plotting, I covered a little basic about very useful package in R, which is Gplot. I recommend you to work with Gplot if you want to really get mastery over data analytics. I'm not saying mastery over R. Data analysis is a very much more advanced package in data analysis. If you want to learn this, you can do a lot of thing in R and in terms of data analysis. So I think I covered a little background on this. And in the next class, in the next video, I'll discuss about how to load panels in R and work with even more advanced package of data analytics or advanced package of plotting. Till then, bye bye.